Alright, so here we get to see, find the shortcut for using limits to evaluate integrals. So for the past two lessons, we've been looking at evaluating area using a definite integral. We evaluate the definite integral using a limit. So you don't have to write all this. It's just another example of how we use a limit, but I'll talk about the steps. So we have f of x. We want the area, instead of going from a to b, let's go from 0 to a. So from 0 to a, we have this notation where we have the y value, or the height of a rectangle, times the width of a rectangle. And the x value is determined by going 0 plus the width of the rectangle. The width of the rectangle. So one rectangle is a minus 0 over n. So each rectangle is a over n, and that's why we have this. And we just add a bunch of rectangle widths to get to the next x value. So now we, instead of f of that, the function is x squared, so we just square that. And we come down to squaring it, we apply that. This will be a cubed over n cubed and I squared. A cubed over n cubed doesn't matter for the summation. We just care about the I. So summation of I squared is this formula. This expands to that. And now let's put n cubed under each of these. So n cubed under n cubed gives us 2. If we divide this by n cubed, we have 3 over n. Divide this by n cubed, we have 3 over n squared. And just put the 6 out in front. As n goes to infinity, that's 0 and 0. So we have 2 over 6, a cubed. And we get a cubed over 3. But, well, not yet. Let's look at how is this going to help us find the shaded region between a and b. What's going to happen if I have 0 to b f of x dx? The integral of f from 0 to a is a cubed over 3. So from 0 to b, it's b cubed over 3. And then to find the desired region, we can go find the area from 0 to b, subtract the area from 0 to a. So if we wanted to do from a to b, we're going to have x squared dx, and it ends up being b cubed over 3 minus a cubed over 3. Now, we just got this from our results here, but this is also, this is pointing us to the fundamental theorem of calculus, because instead of writing it out like this, where I already calculated this area, and I calculated that area using limits, and then subtracted, let's see how b cubed is related to x squared. The antiderivative of x squared, instead of writing it like this, let's write it like this. The antiderivative of x squared is x cubed over 3. And then if we throw in that notation, now we have b cubed. We substitute the b, substitute the a, and that's what the fundamental theorem of calculus tells us to do. We do the antiderivative, we substitute the limits, and then subtract. So we can see how all this arises from this procedure that we just did, where we go 0 to b minus 0 to a, and that will give us the desired area. And then we also see that the antiderivative just happened to come up out of doing the limit. So the proof of that is, the proof allows us to see that it works for all functions, not just x squared. But we just saw it for x squared, and that's as far as we're going to take any proofs. So now that we know the fundamental theorem of calculus, we don't have to use limits anymore. And we can just do antiderivative, plug in the 3, substitute the 3, substitute the 1, and subtract. So here we have 3x, and that'll be add 1, divide. Here we're going to have a 1, so we have 1 plus 1. And here we have x to the 0, so we have x to the 1 over 1. And then we substitute a 3, substitute a 1, and subtract. So we just reduce that, and we're going to have 3 cubed plus 5 times 3 squared minus, let's put the 1 in there, 1 cubed plus 5 times 1 over 2 minus 4 times 1. And that's 9 times 5 is 45. We have 9 plus 45 over 2 minus 12 minus 1 minus 5 over 2 plus 4. Just make sure you distribute the negative. All that simplifies to 38. All right, from negative 1 to 1, t cubed minus 9t. Pause the video and try that one. We do the antiderivative. From negative 1 to 1, substitute the 1, 1 over 4 minus 9 over 2. Then we'll substitute the negative 1. Negative 1, I'll go ahead and put that in there. Maybe you're wondering what's happening to all that. But just because it's a 1, you don't need to put that. But here, let's make sure we know that that is to the 4th power. And here we have negative 1 to the 2nd power. So 1 over 4 minus 9 over 2. This is positive, and then we have a negative. This is positive, negative, negative. So we add all that up, and we get 0. Also, when we have a definite integral, when we have an indefinite integral, we always have a plus c. And so maybe you're wondering where the c goes. Well, if we wrote a c here as part of this antiderivative and a c here, that means we'd have a c and then minus c. So the c always goes away. The constant of integration goes away, and you don't have to write it. If you did write it, it would always go away. Okay, so now let's just deal with some radicals. Here we'll distribute before integrating 2t to the 1/2 minus t to the 3/2. T to the 1, t to the 1/2, we get t to the 3/2. Now we have 1/2 plus 1 is 3/2 divided by 3/2. 3/2 plus 1 is 5/2 over 5/2 from 0 to 2. Alright, so this is going to be, if we divide by 3/2, we're multiplying by 2/3, so this would be 4/3. That's 2/3 times 2 is 4/3, and then 2 to the 3/2. Alright, this is 2/5. 2 to the 5/2 minus, putting a 0 there, we get 0 minus 0. Alright, this is square root of 2 cubed. square root of 2 cubed, and here we have the square root of 2 to the 5th. We can take 2 of these 2's out as a 2, so that's 8/3. And we can take 4 of these 2's out, and that comes out as a 4. So we have 8/3 minus 8/5 ends up with 16/15 radical 2. All right, you try this one, and make sure you change that x to have a negative exponent before you integrate. Pause the video. All right, so we have a radical 2 over radical x, but radical x in the denominator is x to the negative 1/2. So that's how it should be rewritten. The radical 2 can just be on the outside, and then we're going to add 1 and divide. So we have radical 2, let's put the 8 in there. Dividing by a 1/2 means multiply by 2. So we have 2 square root of 8, that's square root of 8, minus 2 square root of 1. Square root of 8 simplifies to 2 radical 2, so we have 4 radical 2. 4 radical 2 minus 2. And we can distribute the radical, so that'll become 2 times 4 is 8 minus 2 radical 2. So everything's pretty routine, unless we have something like this. And we don't have a rule for this. We have to break this up into, we don't have a rule for absolute value. We have to break it up into its parts. So if we look at the graph of this, we know it has x-intercepts at 3 and 1. Parabola, it goes like that. And then what does the absolute value do? It reflects that up. Any negative y values become positive, and so it's just going to go like that. And so now we have to integrate from 0 to 4. So we have to integrate from 0 to 1, the original function, and then from 1 to 3, the negative of the original, and then we have to go from 3 to 4 of the original function. We do have a little shortcut here due to symmetry, and that is this region is equal to this region. So we can really just calculate that integral times 2, and then we can do this integral in here. Alright, so that is going to be the integral from 0 to 1 of the original function plus the integral from 1 to 3 of the negative of the original function. So we're just using the negative because the original function is down here. We want it to reflect to go up there. Okay, and we have 2 here because of this region being equal to that region, so we can just do that once. All right. So let's do the antiderivative. And we have x cubed over 3 minus 4x squared over 2 plus 3x. Two of those from 0 to 1. And here we're going to have negative x cubed over 3 minus 4x squared plus 3 over 2 plus 3x from 1 to 3. Alright, let's substitute a 1 into there, and we get 1/3 minus 4 over 2 is 2 plus 3 minus, put a 0 in there, and we get a 0. Okay. Then we have to put a 3 in here, 3 cubed over 3, that's a 2, 3 squared, 3 times 3, and then we put a 1 in there, 1/3 minus 2 plus 3, no more minus. Okay, so we put the 3 in, we get all of this, and then we put the 1 in, we get all of that, and we subtract. So let's see if there are any shortcuts we can do here. If we have 2 of these, 1/3 negative 2, 3, and we have 1/3 negative 2, 3, we can get rid of some of the arithmetic by just canceling that or combining them. So we really have positive 2 of these, and we're going to have get rid of that 0. Let's distribute the negative. So it's going to be minus, and that's 27 over 3. This will be plus 18. And here we have minus 9 plus 1/3 minus 2 plus 3. And we have 2 of these plus another one, so we really have 3 of these. 3, 1/3 minus 2 plus 3. Negative 18 plus 18, that's nice. Right, let's multiply by 3 and we get 1 minus 6 plus 9, and that's 4. All right, let's, well, you try this one and just graph it on your phone or on the calculator to make sure you know where the 2 parts of the graph are. We're looking for the vertex of the graph, and then we can break it up and integrate each part. Pause the video and try that one. So we see that it's shifted right and down. There's the vertex, and it's reflected down because of the negative here. We want to find the area between the graph and the x-axis. So we could look at finding this region and this region. We're going from, just go from 1 to 4. I'll just call that 4, and then it'll be a little more accurate. We don't need that part. So we need from 1 to 3 here, and then from 3 to 4 there. We have to represent each of these. So this line is going to be negative 3, and we're going to use, this has the positive slope, so we're going to have minus, and we're going to have negative x plus 3. So when you have absolute value, you're going to have a positive and a negative. And just to make sure we're getting that right, if you distribute that, then this equation matches that line because it has a positive slope. Then this one is going to be negative 3 minus, and we're going to use the original function in there. This has a negative slope, and it has a y-intercept of 0, which looks reasonable there in the graph. All right, let's integrate this from 1 to 3. And we'll say that's negative 3 minus 3 plus x. So negative 6 plus x. All right, and then we're going to have from 3 to 4. From 3 to 4, we're going to integrate this. This is going to be negative 3 plus 3 minus x, which is negative x. So the graph of this line is y equals negative x, and we're going to integrate from 3 to 4. Okay, and that's going to be negative 6x plus x squared over 2. From 1 to 3, here's going to be negative x squared over 2, 3 to 4. Substitute the 3, subtract the 1, and then substitute the 4. Subtract the 3. We have negative 18 plus 9 over 2 plus 6 minus 1/2. Distribute the negative. Here we have 16 over 2 is 8. And then we're going to have a plus 9 over 2. All right. So we have 18 over 2 minus 1/2. That's 17 over 2. And then we'll have 6 minus 8 is negative 2. And that's negative 20 plus 17 over 2. So we have negative 40 over 2 plus 17 over 2. And we'll get negative 23 over 2. So all that is just because we have the absolute value. We can also come back and let's just review some trig antiderivatives. All right, pause the video and try that one. So we do the antiderivative of 2 and the antiderivative of cosine. Evaluate from 0 to pi. 2 times pi over 2 sine of pi over 2 minus 2 times 0 sine of 0. So that's pi. Sine of pi over 2 is 1, and we get 0 over there, so pi plus 1. So you just have to remember the trig antiderivatives. Okay, almost done. Let's find, this is the second fundamental theorem of calculus. If f is the integral from 1 to x of t squared plus t dt, find f prime. And we'll just, when we learned this the first time, we looked at 3 different ways of doing it. And let's just do the short way. So f prime of x is going to be, it's helpful if you set it up like this. And we substitute x into the function. Then we have to go times the derivative of x, and this is the chain rule. If we're doing the derivative of something, we also need to do the derivative of the inside. Now we put the 1 in, times the derivative of 1. So all of that is 0, and we get x squared plus x. So if f of x is x to x squared of 2t minus 1 dt, then you try that one. Find f prime. Alright, pause the video and try that. Plug in x squared, and we have 2x squared minus 1, substituting x squared in for t, times the derivative of x squared. Then we substitute the x in for t, times the derivative of x. And now we can just distribute 4x cubed minus 2x. Then we'll have a minus 2x plus 1, 4x cubed minus 4x plus 1. Oops. Average value of f of x equals x squared minus x on 1, 2. So this is using the mean value theorem for integrals. The mean value theorem for integrals only requires that the function is continuous. The mean value theorem for derivatives required that the function was differentiable also. So here, the mean value theorem, this is manipulating the mean value theorem to find the average value. That's a really common question. Find the average value of a function, and that's where we have 1 over b minus a times the integral from a to b of f of x. So now we just do 1 over 2 minus 1 from 1 to 2 of x squared minus x. And that's x cubed over 3 minus x squared over 2 from 1 to 2, and that's 1 over 1. Substituting the 2, we have 2 cubed over 3 minus 2 squared over 2, and then we have 1/3 and 1/2. Substitute the 2 in there, substitute the 1, and now we have 8 over 3 minus 4 over 2 minus 1 over 3 plus 1 over 2. Alright, let's combine. We have 8 minus 1, 7/3, and negative 4 plus 1 is negative 3 over 2. If we get a common denominator, that'll be 14 over 6 minus 9 over 6, and we get 5 over 6. Okay, so I think average value is easy enough. We don't have to do another example, and we'll stop there.